Welcome, ladies and gentlemen. So what I'd like to do is show you how to maximize and minimize our objective function when given a set of constraints for a linear programming problem. Now, obviously, again, a lot of these have some real-world context, but in this case, we're just going to kind of go through the nuts and bolts here of how to do the problem so we can identify the minimum and the maximum. Now, the main important thing is we need to identify what our constraints are and what we need to identify the feasible region using our constraints. And not only do we need to know what the feasible region is, we want to know what the vertices are, where those constraints intersect that make up the feasible region. We're going to take those intercept, the x and the y values of where they intersect, those points, and plug them into our objective function to maximize and minimize it. So the main important thing is when we're going to go ahead and graph this, you can see, though, I have three equations that are not in slope-intercept form. Now, I have gone through this quite a bit here, and I don't really actually, yeah, I can do this. OK, so let's do 2x plus 3y is greater than or equal to 6. We have 3x minus 2y is less than or equal to 9, and x plus 5y is less than or equal to 20. OK. So again, ladies and gentlemen, remember the first thing we're going to do is subtract the 2x on both sides. We want to solve for y. So therefore, just to save some time, that's going to be 3y is greater than or equal to a negative 2x plus 6. Then I'll divide by 3, so I have y is greater than or equal to a negative 2/3 x plus 2. Here, I'll subtract a 3x on both sides, so I'm left with a negative 2y is less than or equal to a negative 3x plus 9. Divide by negative 2, divide by negative 2. Remember, you're divided by negative 2, so now you must flip the sign. So that becomes a positive 3/2 minus 4.5. And then the last one, I'm going to subtract an x here. So I have 5y is less than or equal to negative x plus 20. Divide by 5, divide by 5. Y is less than or equal to a negative 1/5 x plus 4. OK, so those are going to be our values plus our x is greater than or equal to 0 that we're going to want to graph. All right, so I'm going to go ahead and create a table, or I'm sorry, a graph, to go ahead and graph the points. So the first one here, x is greater than 0. That's the easiest one to graph. That's just going to be a vertical line at 0. And greater than is going to tell you all x values are going to go to the right. OK, the next one is y is greater than or equal to negative 2/3 x plus 2. So I'm going to go up 2. That's my y-intercept. And then my slope is going to tell me to go down 2 to the right 3. That is greater than, so that's going to be values above. Then the next one is I'm going to go down to negative 4.5, negative 1, 2, 3. Oops. 1, 2, 3, 4. And 4.5 is going to be halfway between 4 and 5. And then my slope for that one is up 3. So 1, 2, 3 over 2. Up 3, 1, 1, 2, 3 over 2. Looks like a cross is right there. And that is greater than, so that's going to be above. And then the last one is going to be positive 4, 1, 2, 3, 4. And my slope is down 1 over 5. 1, 2, 3, 4, 5. So down 1 over 5. 1, 2, 3, 4, 5. OK, so therefore you can, and that is below, so you can see here, that's going to be my feasible region. So you can see my feasible region here is basically made up of this little polygon here. Now let's go ahead and see what the coordinate points are. Well, we have this first one, which is 0, 2. The next one is 1, 2, 3, 3, 0. This one is 1, 2, 3, 4, 0, 4. And this one is over 1, 2, 3, 4, 5, up 1, 2, 3, 4. Yep, so 1, 2, 3, 4, 5, up 3, 1, 2, 3. So 5, 3. And it would be best to use graph paper. I'm just trying to do my best, obviously, to make sure I have those points. But again, now to determine the value of the maximum of our objective function, we're basically going to plug in the x and y of each of these coordinate points into our objective function. So the first one I'll have 4 times 0 plus 3 times 4. The next one is going to be 4 times x, which would be 5, plus 3 times 3. Next one is going to be 4 times 3 plus 3 times 0. And the last one is going to be 4 times 0 plus 3 times 2. Let me just see if I got these. Cool. All right. Awesome. So in this case, 4 times 0 is 0, plus 3 times 4 is 12. Over here, we have 20 plus 9 is going to be 29. Here I have 12 plus 0, which is 12. And here I have 0 plus 6, which is just 6. So therefore, we can now determine that our maximum value is 29, or at the coordinate point 5, 3, and our minimum value of this objective function is at 6, or at the coordinate point 0, 2. So we've identified the values of vertices that produce the minimum and the maximum of our objective function. OK, now let's go and get into the last one here. So we have 3 constraints. They're all linear. So to write my constraints, I could subtract an x here. So I'd have y is less than or equal to negative x plus 27. The next one, I could just add an x to both sides. So therefore, I'd have y is less than or equal to x plus 11. And then over here, I would have to subtract a 2x on both sides and then divide by 5. So I would be left with y is less than or equal to a negative 2/5 x, and then 90 divided by 5 would be 18. Let's see, 5 divides into 100 20 times. So it would be 18. OK, so now let's go ahead and graph that. You can see all my y-intercepts are positive. Very interesting here. So I need to go all the way up to 27. So let's go by 2. Let's go by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. So we're going to go by 2s. However, over here, let's just go by 1s. 1, 2, 3, 4, 5. OK, so the first one is up to 27. Ooh, I need to figure out those. Up to 27. Which is right there, between 26 and 28. And then I'm going to go down 1 to the right 1. This is confusing. I'll go by 1s. I just don't have grid paper, and it just makes me more confused. OK, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 25, 6, 7, 8, 9, 30. OK, that's 30. I'm going to go by 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5. OK, so I'm going to go up to 27. So 30, 29, 28, 27. I'm going to go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And that is going to be a line, and that's going to go below. Try to do my best here. The next one is going to be up to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That has the same, that has a positive slope, so it's going to be up 1 over 1. Up 1 over 1, up 1 over 1, up 1 over 1. So that's 3. Up 1 over 1 is 4. Up 1 over 1 is 5. Up 1 over 1 is 6. Up 1 over 1, 6, 7. So at 7, x equals 7, that should be at 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. OK, so that should be at 7, 20. I believe it's going to be close. That's 11. And then my last one is at, and that's below. Using a graphing calculator would be the best. Then I have up to 18. 1, 2, 3, 4, 5, 6, that's 11, 12, 13, 14, 15, 16, 17, 18. And I'm going to go down to 1, 2 over 5. 1, 2, 3, 4, 5. So down to over 5. 1, 2, 3, 4, 5. Let's call that a point. 5 would be 16. Now, I know I'm probably going to be a little bit wrong on this one, but I'm just going to go ahead and go with what my values look like. And this one, so I'm going to go with, let's go with 10, 11, 12, 13, 13 up to 11, 12, 13, 12. Okay. Now, obviously, we're going to have to use graph paper or graphing utility. For this basic one, you can see that I don't really have those options. But you can see here, the issue with this one, the main important reason why I wanted to do this problem is you can see that my feasible region is unbounded. All right. So we're still going to choose the values here. That's 20, 21, 22, 23. Let's make that 23, 0. So we're still going to use our objective function to identify the max and the min. And yeah. So let's see here. Our objective function is 2x. Oh, that's pretty close. I'm saying 23. It looks like it's 21, actually. But that's OK. So let's say the objective function, we'll just plug in our values here. So this one is 0, 11. So I have 2 times 0 plus 5 times 11. Then I have 2 times 5 plus 5 times 16. My next point is 2 times 13 plus 5 times 12. And my last one is 2 times 23 plus 5 times 0. OK? Now, the problem is, let's go through this. So we do 0 times 5. That's going to be 55. That's going to be 60 plus 2 is 70. Here, that's going to be 26, 5, so that's 60. Wait a minute, that's not 60. That's 50, that's 80. That's going to be 90. This one, that's 60, plus 26 is going to be 86. And this one is going to be 46. OK? So again, I'm looking at my answer of what I did here. And I can see that I do not have the same values, and that's going to be due to my graphing ability on this table. So I apologize for that. But if we're going to determine the maximum, 90 is going to be the maximum, or when we had the values at 5, 16. However, the minimum, since this is an unbounded region, there is no minimum. OK, so I'd really love to use a graphing utility or just to graph this on some graph paper, because I believe the correct answer was 42 was the maximum. So I'm obviously way off on my graph. So I want to make sure I double checked everything. But hopefully you at least understand the idea of what you're supposed to be doing. Kind of like that one as well. Thanks.